Hello, hello.
Hi.
How's it going? I have been pushed with everyone, so they should be filtering here in a second.
Morning,
Uh,
everyone. Good afternoon, good evening. I think the audience is all over the world right now.
yes, put it in the chat, everybody, where you're calling in from. So AI is evolving beyond standalone models. Today, the more advanced applications rely on compound AI systems. Our next speaker, Lynn Chow, is CEO and co-founder of Fireworks AI, where she is leading the charge in AI-powered application development. She's going to talk about compound AI systems for modern application development. And with that, I will hand it over to you.
Thanks, and exciting to see everyone across the world attending this session. And hello from Bay Area. Cool. Before I start, I want to quickly introduce us, who we are. So we are the Fireworks team. Our founding team has been running PyTorch at Meta and built up Meta's AI infrastructure for 5 years before we started this company. And yeah, we are a startup backed by both Sequoia and Benchmark. And we have been running more than 50 trillion inference per day, supporting Meta's workload before. As we have been building PyTorch, a little bit interesting journey about PyTorch is start in 2000, I think 2017, 2016, when there's no, it's kind of very small framework adoption wise. Here in this chart, this is a framework adoption chart for AI. PyTorch is the dark orange one. And till today, it is a dominating AI framework, especially in the most advanced AI space. We are talking about generative AI all the time. PyTorch has been used everywhere. Almost all models, all the GenAI models are PyTorch models, including the ones that in open source world and in the closed source proprietary model providers such as OpenAI and Anthropic. So generative AI is a very, very interesting and disruptive technology. The fundamental difference it's kind of creating is the notion so-called foundational model. The foundational model can absorb knowledge from internet, where it's kind of word knowledge, and therefore application developers can easily access AI tech without starting a big team to train data from scratch. This fundamentally is unlocking so much innovation at the product and the application tier. So we would like to touch on all different kind of use cases. We have onboarded various different kind of customer in production. So to me, 2025 extremely exciting year that we're going to see a huge amount of innovation and disruption in the application space because of the GenAI widespreading adoption curve. So speaking about that, I would like to talk about, open source and closed source. Isn't this the most interesting topic these days, especially starting this year? As you can see from this chart, by the way, this is kind of a little bit old chart. And I added a recent development on the right-hand side. At the beginning, about 2 years ago, when we started this journey, there's only closed source, closed models. Right. So how to read this chart, x-axis is timeline, and y-axis is the accuracy and the quality of the models. The red dots are closed model and green dots are open models. Over years, as you can see, the green dots are approaching red dots until recently. We are no longer talking about convergence across open and closed models. We're talking about parity. Especially this year, from end of last year, Christmas Day, to early Jan, DeepSeek open source their V3 model, and the R1 model. V3 is a chat model, R1 is a large reasoning model, with on par quality to the best closed source model from OpenAI and Anthropic. So this is mind-blowing, but this is just a trend that before we worked on PyTorch as open source project, I really believe in open science because the community is much, much bigger than any company. In addition, add up together. So, and this advancement mobilize all the intelligence across every single developers and researchers, build out the ecosystem, build out the tool chain, deepen the open source development. Is gonna accelerate the quality evolution. And there's so much talk about DeepSeek by itself. And I just want to, today I want to use a little bit of time to show you what DeepSeek can do on fireworks. So here you just see like using a logical reasoning model to solve a math problem. And the model actually try to generate chain of thoughts in multiple different ways. In the example I just showed you in 2 different ways, and then at the end validate result. So it's very solid in conducting logical reasoning from different angles. And the next example is for coding. Sorry. Okay, let me see how to run this. All right, so I just show you multiple capabilities. For example, the last one, when we actually gave a screenshot to DeepSeek, it's actually using Fireworks agents, where we combine a vision model with a DeepSeek model to make any large language model able to see. So this is going through actually a Fireworks compound AI stack, and I will talk about that briefly next. So before I start to talk about what's happening underneath and how you can utilize Fireworks to develop on top of GenAI tech, I want to share that Fireworks has powered many GenAI innovation in production across a wide range of production use cases, and a wide range of adoption across AI native companies, digital native, and traditional enterprises. For example, Uber, DoorDash, Verizon, HubSpot, Upwork, GitLab, Samsung, and many other big enterprises, they have been our customer and heavily innovating to use GenAI to push their consumer-facing, prosumer-facing, or internal productivity tools. We have also on board state-of-art AI native companies such as Cursor, Quora, SourceGraph, Cresta, ContraPod, Superhuman, and so on. So the whole entire development on GenAI built on top of Fireworks is super exciting, and that is the mission we're having, is to enable AI to all developers and enterprises. Not in 5 years, that's the journey we've been through at Meta, but in one day without an army of machine learning engineers and infrastructure engineers. Now I want to break down the GenAI development into 2 phases, and that's kind of the journey you're going to go through. One is the inner loop. Inner loop is a heavy experimentation. You have the product ideas. You want to build some new apps, and you are testing hypotheses, and you want to do fast iteration. So that's the inner loop. The velocity of iteration is extremely important. And there's an outer loop that you find a product market fit, you want to bring into production, and all you're concerned about is cost of scale, performance in terms of low latency, and scalability and reliability. So those two are fully covered by the Fireworks platform, and you can start with us and scale with us easily. So experimentation pattern is very similar to code development when you are experimenting your app ideas and also experimenting models. And especially a lot of companies are doing model tuning and adjustment towards their inference workload pattern. It's very, very similar to code development, as in you have branches and then you have trunk. So oftentimes this kind of development and experimentation leading to large number of variety of model versions that you're testing at the same time. It can easily get into 100 different versions, and in the naive way, you will need 100 GPUs to run your all different kind of experimentation. 100 GPU is very expensive to operate. So we develop a technology where we can significantly compress down your memory footprint. So instead of using 100 GPUs, you can use one GPU to sustain all different 100 versions of experimenting testing you want to do. So that is a huge amount of cost reduction and productivity improvement within your team. And second, I want to quickly talk about production. So when it comes to production, for app developers, there are things that stay the same. There are things that's changing. For example, consumer personal-facing application, it requires highly interactive latency to make the app very engaging. And second is it needs to quickly scale to a large number of users. When you have the product viability, when you scale, you don't want to scale quickly to bankruptcy. So that's kind of the challenge. This doesn't change, but GenAI create a lot of challenge because GenAI models are on a higher spectrum of model complexity and size. So it makes interactive latency and like high cost efficiency very, very hard. The other thing that has also changed for app developer to adopt GenAI is the model is probabilistic, not deterministic, so it can hallucinate. To ground the model into facts and truth is new as a new way, as a new approach, a new skill set to gain to use GenAI. The second is GenAI models has limited knowledge, although it feels magical. The knowledge is limited because the training data for GenAI model to learn is not infinite, it's finite. So we also oftentimes need to expand the knowledge beyond single model. So those are the variants and invariants of application development before and after GenAI. To address all this interesting shift and differences, Fireworks, we release our compound AI system. It's a very complex product offering. I would like to kind of simplify that for you all here. And this is in general, I think, leave Fireworks aside. In general, we will look at the overall GenAI development stack evolve into this form and shape. At the bottom layer, we have a distributed inference engine to bring the highest interactive latency experience and cost efficiency to our user. On the bottom left, we have the optimizer that is going to help you personalize quality, latency, and cost in addition towards your specific use case without you heavily kind of deeply understand how to do it. And then on top of that, we have our model stock where we serve hundreds of GenAI models across various different modalities, including our laser focus on large language models across chat and logical reasoning, but also in adjacent areas such as audio, vision model, embedding models where we can do semantic search, image generation, and so on. And on top of that, we are expanding knowledge beyond single model by combining multiple models and other knowledge source together to create this compound AI stack. So I'm going to decompose that a little bit. And you may wonder, why do you care about other modalities, right? So why LLMs is not enough. Oftentimes when people build any kind of assistant, they quickly go beyond text because typing is slow. And then they are adding audio capability to automatically transcribe and then generate audio back. So that's why audio and text are very closely integrated. And vision, oftentimes information is not just in plain text; they are in PDFs, pictures, images, and screenshots. So the combination of vision and text is very powerful, as I just showed you in the demo. All right, so we have very sophisticated inference stack and optimization stack. I will not go into details today, but this is like, if you're interested in trying out, please reach out, and it's very easy to get onboarded. Again, we have a lot of proprietary technology to accelerate inference. Our speed is top notch. And as you can see from this comparison, we are 12 times or order of magnitude faster than any open source alternative. Again, this is a quick recap of what kind of optimizer we offer. And the idea here is, as an app developer, think about your product, right? You are trying to optimize a three-dimensional space across quality, latency, and cost. And this optimizer we are offering, it allows you to navigate in this three-dimensional curve. The idea here is you give us your objectives, optimization objective, across quality, latency, and cost, as well as your inference workload pattern. And then we will go through this optimization process. Think about that works similar to how compilers work. And we spit out and set up a much faster inference engine with higher quality for you automatically. And of course, we have many other complicated technology, advanced technology to help you go faster, including advanced caching mechanism, where we see a lot of repetitive prompts where we don't have to recompute everything. So, so we have multiple layers of semantic cache to make your inference fast and low cost. As I mentioned, single model is limited. It doesn't. It's magical, but it has a lot of limitation. All the way from it hallucinates to a single model has specialized strength. It cannot be the best across all different fronts, and single model has limited and sometimes outdated knowledge. To address that, the industry is going to compound AI systems. As you may heard, another way to talk about compound AI is agents. And 2025 is the year that we will see a lot of uptick of building up agents, and Fireworks were ready to support all these workloads. As a matter of fact, we have already onboarded many compound AI use cases and agentic workload in production, all the way from call center automation to product catalog cleansing for better search relevance, to medical claim automation so that we can make lawyers much more productive, to team coordination in a kind of in a game setup, to sales call summarization from the recording. So the use case has been very broad when it comes to compound AI. We have also extended the compound AI. We also onboarded use case that integrate not just multiple models, but other external APIs or internal private APIs, from internet search to information retrieval APIs, to databases, to various kind of document stores, graph knowledge base, and so on. So as I just showed you, there are so many different use cases, mental technology to power all of that from our company stack.
Hey, Lynn, we've got about 30 seconds left.
All right. So to tie everything together, Fireworks is the platform, is kind of all-in-one platform for your application development, building on top of GenAI tag. We offer the best quality, lowest latency, and lowest cost for you. It's extremely easy to get started. Please scan barcode here, and we will have initial credits for you to get Bootstrap and get start using Fireworks. I love to hear your feedback and cannot wait for interesting application product you can build on top of us.